And recording. Let's get to Spiral17. This won't be due until Friday, only because weather and the video's late and everything just added. Delay. Okay, so let's get started. The equation 5m plus 7 equals 2m plus 7 plus 3m has one solution. Infinite solutions or no solution. So I think if you remember, let me grab my... So on one side, and I can write over here, on one side I have 5m plus 7. On the other side I have 2m plus 7 plus 3m. If you noticed, then that I can combine this 2m and 3m, and these 2m plus 3m gives me 5m. So I could have rewritten the right side over here as 5m plus 7, and now I know that the left side, which is 5m plus 7, and the right side, which is also 5m plus 7, are equivalent. If you remember from the discussion that we had in class, if both expressions are equivalent, the one on the left and the right, the one on the right, you're going to have infinite solutions. Okay, and to prove it, I'm going to take this back. I'm going to erase this. To prove it, I'm going to select a few values for m. I'm going to make m equals 1, m equals 0, and m equals 2. Just 3 easy numbers, and let's see if they work. So let's pick m equals 1. It'd be 5 times 1 plus 7 on this side. 5 times 1 is 5, plus 7 is 12. So on the left side, you get that it's equal to 12. On the right side, it's 2 times 1 plus 7 plus 3 times 1. 2 times 1 is 2 plus 7, and then plus 3 times 1, which is 3. So if I add these three numbers, 2 plus 7 is 9, 9 and 3 is 12. Guess what? It equals 12 on the other side. So that's okay. It worked for 1, so let's try 0. 5 times 0, and I'm just not going to, all right, I'll substitute. 5 times 0 plus 7. 5 times 0 is just 0, and I end up with 7 on the left side. On the right side, I get 2 times 0 plus 7 plus 3 times 0. So we know anything multiplied by 0 is just 0. So this is going to be 0. That's going to be 0. So I'm left over with 7. So it worked for 0 as well. And guess what? It will also work with 2. Okay, so this particular equation, 5m plus 7 equals 2m plus 7 plus 3m, has infinite solutions. Okay, so one way of trying it is just selecting a few random values for m, substitute it. Okay, and in this case it just worked out. Number 2, combining like terms. Okay, so on the test, a lot of you were combining, putting circles, and this is a 12, it's a constant. You thought this was a constant, that was a constant. You were circling these and then moving them so they can be next to each other, and you put a little square around 3m and a little square around am. The only problem with that is that there are parentheses here. You needed to get rid of the parentheses before you did any of the circling and the squares. So let's do that. So here we have a 12, which is going to just hang out for a little bit. And that's 5 over here is going to be multiplied, be distributed to the terms inside. So 5 times 3m is 15m. And then plus 5 times 4 is 20. Now continue with plus here. And we're going to multiply the 2 times 8m. You're going to get 16m minus, and the 2 times 3 is going to give me 6. Now I can move, now that the parentheses are gone, I can circle, square, and do all that stuff. So I'm going to circle the 12. That's a constant. 20 is also a constant, so I'm circling the 20 with the addition sign and the 6 at the end. I'm going to put a rectangle around 15m and a rectangle around 16m. Move things around. So I'm going to get 12 plus 20. And I get to minus 6. Move the 15m over here. And I'm going to 16m. So all my m's are next to each other. Now I can combine like terms. I'm going to combine these three guys here. 12 plus 20 is 32 minus 6. So 32 minus 6 is going to give me 26. So these three gives me 26. And then I'm going to add 15 and 16, which is going to give me 31m. So my final answer is 26 plus 31m. Okay, so this is a division problem. He has 4 and 3 cups of dough, and how many dumplings can I make if it requires 5/12 of a cup of dough? So let's set up the problem. You got 4 and 3/4 divided by 5/12. Okay, so the way we learned it this year, we're going to change, first of all, we're going to change this mixed number to a proper fraction. So you're going to go like this. Multiply 4 times 4 is 16, then add 3, you get 19 over 4. And divide by 5 over 12. Okay, now they're both fractions, no whole numbers, no mixed numbers, I should say. Now we can find an LCM. The LCM of 4 and 12 is just 12. This one is easy because it's already a 12, so nothing changes. But the 4 here changed to a 12, so was it times 3 to change to 12? So I'm going to multiply that times 3. And 19 times 3 is 57. Okay, so now that my denominators are the same, it allows me to cross these two. And I can rewrite this 57 over 5 like this. 57 5. And I want to change this to a mixed number. 5 goes to 57 10 times. 7 left over. Nope, not 10 times, sorry. 11 times because it's 55. 2 left over 5. So how many dumplings can I make? How many whole dumplings can I make? I can make 11 whole dumplings, and I can make a little bit more of another one. But as far as completely whole dumplings, just 11. Ooh, Thomas weighs 238 pounds and decides to go on a diet. He wants to lose 8 pounds per week. Write an expression to represent the situation. So, 2 things here. So, what is he right now? He's currently at 238 pounds. He wants to lose. So lose is definitely not something you're going to add, but instead, in this case, you're going to subtract. And he's going to lose 8 pounds every week. And that would be your expression. Okay, so let's see how much he weighs after 7 weeks. So that's 238. And every week is going to lose 8 pounds, so 7 weeks. So we're going to take out the W here and replace it with a 7. And it's going to be 238 minus 56. And 238, okay. Two 238 minus 56. You got 2, 13 minus 5 is 82, 182. So after 7 weeks, he's going to be at 182 pounds. Not bad if you say, it's pretty good actually. Find a GCF and LCM of 48 and 18. We can actually do 2 things at once here. 8, 48, and 18. Set up the ladder method. Let's see. 4 goes? Does 4 go? No. 3. 3 goes. 3 goes in 48 16 times. 3 goes in 18 16 times. Can I go on? Yes, I can. I'll try 2. 2 goes 16 8 times. And 2 goes in 6 3 times. Can I go on? No, I am done. So, because I can't go on, nothing goes into 8 and 3. So the GCF is the product of these 2 numbers, 3 and 2. So you get 3 times 2. So the GCF is 6. The LCM is a little bit different. The LCM is a product of, and I'm going to change colors. It forms a now, so it's going to be the numbers on the sides and the numbers on the bottom. So it's 3 times 2 times 8 times 3. 3, 6, and you get 24 times 6, 144. So the LCM is 144. Okay. Find the opposite of -4. Explain how you know the answer. Well, I use a number line. 0, 1, 2, 3, 4. On this side you got -1, -2, -3, and -4. To be opposite, for a number to be opposite of another, they have to be equally distanced from 0. So if you're right here, right now, you are 4 steps away from 0. 1, 2, 3, 4. The only other number that is the same distance away from 0 is 4. So the opposite of -4 is here. Now right here. This is the opposite of -4. So, but we want the opposite of the opposite. So the opposite of -4, so you're going to go from here to here, and then you're going to find the opposite of 4, which leads you back to -4. So the opposite of -4 is actually just -4. Okay? Let's say integers from least to greatest. I like to use a number line, you know. So it doesn't have to be to scale, just as long as you know where numbers go. So let's put 0 over here. And let's start with the easy one, 5. So 5 would be about here. -6, well here. -54, well, -6, -7, -8, -9, -10, 11, 12, 13, 14, 15, 16, 19, 20. So actually, we're going to hit -23 first. 23, 24, 25, 26, 27, 28, 29, 30, -50, -54. So this number line needs to be a little bigger. -54 is going to be about here. And you're going to keep going. 51, 52, 53, 54, 60, 70, 80, and eventually you're going to hit -87 over there. And this is a positive number, so it's going to go on this side. So 0, 5, 6, 7, 8, 9, 10, 20, 30, all the way. And 76 is going to be somewhere over there. So here's your order. The biggest number is 76. Second biggest is 5, then 0, then -6, then -3, then -54, then -7. So we're from least to greatest. -87 is the smallest. I'm sorry, yes. And then -54, then -23, then -6, 0, 5, 7. Okay. On a recent supermarket run, Mo bought cereal for $3.89, milk for $1.80, and meat for $15.78, and sausage for $5. There's a reason I'm actually doing this decimal problem, because I saw a lot of you not remembering how to add. There was a test question on the snow question. You didn't know how to add. I believe it was 21.5 plus 4. A lot of you added up this way. Hang on a second. You ended up adding it like this. You got some like this, which gave you 61.5 or 21.5, and you put the 4 over here, which gave you 21.9. Either way, it was a little bit weird. So, little review here on how to add decimals. Okay, so to add decimals, simple. Make sure your decimals are lined up. 3.89 for the cereal, $1.80 for the milk. So here's the decimal, $1.80. Check. The meat was set 15.78, so put the decimal, 15.78. Notice that everything's lined up nicely. And 5 for the sausage. Well, the $5 doesn't have a decimal, so you're going to add a decimal. So it becomes here, the decimal is here, 5. So 5 without a decimal looks like that, and with a decimal it looks like that. You can even add 0, 0 as placeholders if you like, which we need here. Now we can add 9 and 8 is 17, goes 1. This is 24. Bring the decimal down, carry 2. That would be 16 and 26. So your total ends up being $26.47, and you're going to pay with a $50 bill, so you got to subtract. So here's my $50 bill. I'm going to add a decimal and 2 zeros, okay, because my total here has 2 decimal places. So that, again, add a decimal, $26.47. Now you can subtract. We're going to need to borrow all the way out here. And 10 minus 7 is 3, 9 minus 4 is 5, 9 minus 6 is 3, and 4 minus 2. So this is how much change you get. Okay, so the idea is remembering how to add decimals, which was to make sure the decimals are lined up under each other. Ratio of men to women at a PTA meeting was 2 to 7. There were 72 people attending. How many men showed up? So usually you have more women coming to PTA meetings for whatever reason. So there's your ratio, 2 men for every 7 women. So a lot of choices here. So let's do it 2 ways. I'm going to do it 2 ways. One, I'm going to part two. There were 2 men, 7 women, for a total of 9 people attending. Okay, the PTA meeting. There were 72 people, so 72 will go not under men, not another woman, but under total. What's the relationship? Times 8. So here it's going to be times 8. This one's going to be times 8. 2 times 8, 16. 7 times 8, 56. Well, 16 men show up, 56 women will show up, and that will give us a total of 72. Do they actually add up 72? Yes, they do. Okay, so you know it's correct. So how many men showed up? 16. I'm going to do a tape diagram. I'm actually going to do it, so that's way too big. So we're going to create for the men 2 boxes. For the women, we create 7 boxes. 1, 2, 3, 4, 5, 6, 7. So 7 boxes. So 72 does not go on top of the men. Doesn't go here at the bottom to represent the total of men, but instead will go here on the side like this, because it represents the total amount of people. So all these boxes added up, all the people inside these boxes added up gives me 72. How many boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So if I divide 72 by 9 boxes, it's going to give me 8. And that's the number I'm going to put inside. So 8 here, 8. Remember, it's tape diagrams. If you find one number, you find all the other numbers. So if I add the total for the men, I get 16. If I add the total for the women, let's see, 1, 2, 3, 4, 5, 6, 7. It's 56. Notice the same exact answer I got on this side. Okay. Write the prime factor. Well, 5,040. Wow. Excellent number, Mr. Cho. So 5,040. Yikes. I'm going to choose 2 numbers. Ugh. Let's choose 504 and 10. 10 becomes 2 and 5. Circle, circle. They're both prime. 504, I'm going to break it up into 2 and 252. 2 I can circle. 252 I'm going to circle and break it up into 2 and 176. Is that it? 176, 176, 12, 5. No. 126, sorry. 26, 126, 12, 5, 2. Yeah, 126. I'll continue the 126 like this. I'll break it up into 2 and 63. That works. I'm going to keep circling my prime numbers. 63 is going to be 3 and 21. And 21 is going to be broken up in 3 and 7. So once my numbers are prime, I circle, because that tells me I don't have to go anymore. And I'm going to write in exponential form. So let's write this. So it's 1, 2, 3, 4. There are 4 2s. So 2 times 2 times 2 times 2. How many 3s? 1, 2. And 1, 7. In exponential form, we 2 to the 4th times 3 to the 2nd times 7. Okay, my final answer. Takes Peter Pan. 15 seconds to fly 240 feet. How far will you fly? 27 seconds. Yikes. All right, great question. So let's write this as a fraction, okay? I'll write feet on top, time at the bottom. 240 feet in 50 seconds. 15 seconds. And we want to know how much it flies in 27 seconds. Is the relationship this way? Oh, I don't think so. Nothing multiplied by 15 will give me 27. Okay, so let's go up and down. Is 240 divisible by 15? Actually, you know what? I'm not going to do that. I'm going to substitute. Make this fraction. So I'm going to change the 240 and 15 into another ratio here, where we're just going to have a relationship with 27. So 15, if I divide it by 5, if I divide 15 by 5, I'm going to get 3 seconds. And I know I can divide 240 by 5 because it ends in a 0, right? So that would give me 48 feet. So another way of saying 240 feet over 15 seconds is 48 feet and 3 seconds. I divide that by 5 and I divide that by 5. Okay, so no longer going to use this, but instead I'm going to use this. Is there a relationship now between 3 and 27? Yes, times 9. I'm going to multiply the top times 9 and 48 times 9 is going to be 432 feet. Could have done that if you saw a relationship between 15 and 240 going up and down. You could have done what times this 240. Let me see. Yes, there is. It was times 16, so you could have just multiplied. If you went up and down, 15 times 16 gives you 240, and you could have multiplied 27 going up times 16, and that would have also given you 432. Okay. Divide. 85460 divided by 1.4. You can't divide it this way. Okay. We got to make this into a whole number. We're going to move this over. That's going to become 14. And inside, there is no decimal, so we're going to add a decimal. I'm going to move that one over and add a 0. So it's going to become 84560, and then the decimal at the end. So let's do this the long way. 14 goes to 85, 84, 4 times 5, 6. Really, 6 times. 24, yeah. 6 times 4 is 24, goes 2 is 84. Look at that, nice. Bring the 5 down. 14 does not go into 15, so 14 does not go into 5, so I'm going to add a 0 here. Bring the 6 down. 14 goes into 56 4 times. Yes, it does. 4 times 14 is 56. Bring this 0 down. 14 goes into that 0 time. Now bring that other 0 down. 14 goes into that 0 time. So my final answer is 60,400. Huh. Well, I didn't think this was as difficult as I thought it would be. Okay, that's it. So again, this will be due on Friday only because the video was late, and I apologize for that. Okay.